In this video, we're going to look at functions and transformations of functions. So for the sake of this video and the examples we're about to do, I'm going to say that we have some function fx, and in this function we know a coordinate that our function will pass through. And let's just say that coordinate is 2, 2. So we know that our function passes through 2, 2, and if we know our function's knowledge, we can also say that f of 2 will therefore equal 2, because x, when x is 2, y is also 2, x and y. So these are the ways you might see it. Okay, so the first type of transformation in this topic is called a translation. Translation. Now, translation is just a fancy word for shift. So if you see the word translation, you need to be thinking we're going to be shifting our function, or a point on our function. Actually, it's going to be all of the points on our functions, but I'm just going to look at this point in particular. We're going to be shifting it left and right, or up and down. So horizontal shift and vertical shift. So the way we can actually express our shifts and our translations are f of x. Now I'm going to put a horizontal shift in here, so x minus 2. And what this means is this is a horizontal translation or shift 2 units, because it's 2 here, and this is actually 2 units to the right. Now you might think, why is it to the right? This is x minus 2. Well, with horizontal shifts, they're actually the opposite. They get shifted the opposite way to what you think. It's the opposite to this term in here. So this will be 2 units to the right, or you could say 2 units in the positive x direction. So what that would then mean to our point of interest up here is this point would be shifted 2 units to the right, so the x would be changed, but the y wouldn't change. There was no vertical shift there. So the point is going to be 4, 2. The x value, which was 2, was shifted 2 units to the right, so now it's at 4, and the y value didn't change. Okay, what if we did a vertical shift? So this is a vertical shift, would be f of x, and for example, plus 3. Now notice here that the number that I added or subtracted is now outside of the bracket, and this means that we're actually shifting the y value, because fx is actually the same as y. Hopefully if you've been introduced to functions, fx is y, so we're actually adding 3 to the y value. So this is actually going to be a vertical shift, or we could say a vertical translation, 3 units up, or 3 units in the positive y direction. So back at our original point, the x wouldn't have changed because we didn't change the x in the function here, but the y will have 3 added to it, so now it will be at 5, because our original y was 2 and we would add 3. Now you can have a question where they have both a horizontal and a vertical translation. For example, x plus 1, and then I'm going to have plus 4. This is the horizontal translation, this is the vertical. So this will have 2 translations. It'll be a horizontal shift, and this will be 1 unit to the left. It's the opposite to what you think. So 1 unit left, or the negative x direction, and it will have a vertical shift. This will be 4 units up, because we've just added 4 to the y value. 4 units up. So if we looked at our original point and we applied this transformation here, the x would go from 2 to 1 because it went 1 unit left, and the y coordinate will go from 2, and we'd need to add 4, so it would go to 6. Okay, so that's what a translation is. That's the first topic of transformations. The next topic is called, they're called stretches. So I'll put this here. Stretch. Now, stretch, just like it sounds, we're stretching the function, we're making it skinnier or wider. And there's going to be a vertical stretch and a horizontal stretch. So if I had something like this, 3 f of x. Remember, f of x is the y value, so we're actually going to be multiplying every y value by 3. So this is a vertical stretch, and we say by a factor of 3. So if I applied my vertical stretch transformation to our original coordinate up there, the x wouldn't change. We didn't affect the x, so that would still be 2, but all of the y coordinates will be multiplied by 3. So this will become 6, because 2 times 3 is 6. Okay, now the horizontal stretch is the tricky one. If I had f of, let's say, 2x, notice that the horizontals, which is this one up here and this one up here, they've been changed inside of our bracket where the x's are, and the verticals, they're outside of our bracket. This is actually a horizontal stretch by a factor, and it's not actually 2, it's 1 over whatever this number is. So it's a horizontal stretch by a factor of 1/2. Now, that's the tricky one. Now, what that will mean to our function up here, or our coordinate, is that the x value will be horizontally stretched by a factor of 1/2, so that 2 will now be multiplied by 1/2 to go to 1, and the y didn't change. Okay, so that's our stretches. And finally, the third component of our transformations that we need to know are reflections. And there will be 2 types of reflections. We're either going to be reflected in the x-axis, or the y-axis. So if we have negative f of x, this means that all of our y values are now going to be negative. So they're going to actually be flipped vertically. So it's going to be a reflection in the x-axis. Reflection in the x-axis. And the way I remember this is if I have, for example, a function that looks like this, if I have a negative in front of it, it will look like this. So all of the x values are the same, but all the y values were reflected in the x-axis. So what will happen to our original function of 2, 2? Well, the x won't change, but the y will go to negative 2. Okay, and finally, the last reflection is in the blue pen, will be, you might be able to pick it. Let's actually get our blue pen here. It'll be f of negative x. Just like the questions before, if it's inside the bracket, all the x values will change. So this is reflecting in the y-axis. So if I had a function that looked like this, it'll now go to like this. All of the y values will be the same, but all of the x values changed because we changed inside the bracket. And our function, the x value will turn from positive 2 to negative 2, and the y value wasn't changed. Okay, so that's an example of what happens to a singular point. These are the expressions that you need to look out for. If you have a x plus or minus inside the bracket, that's a horizontal shift. If you have a plus or minus outside of the bracket, it's a vertical shift. And you could have both. A stretch outside of our function is a vertical stretch, and inside is a horizontal stretch by 1 over this number. And the 2 reflections are either vertically in the x-axis or horizontally in the y-axis. Okay, I recommend you try some exam questions, and feel free to watch the videos if you need some help. Good luck.